Hello and welcome back. In the last video we looked at implementing functions, specifically function calls, and also built-in or native functions, you could call them, where, for example, we implemented this function called clock that will give us the current time in milliseconds relative to the Unix epoch. And today we are going to look at declaring functions, so defining functions in your script. So a function declaration is a declaration on par with variables or general statements. And the structure we are using is something like this. You write fun and then the function, and the function is a name, parameters, and then a block. So let's start by adding a function declaration. So actually this for loop here I can delete because for loops are just syntactic sugar. And let's add it. So it should have a name, which is a token. It should have parameters, which is a list of tokens. It should have a body, which is a vector. And just to keep it consistent, not sure why I boxed it here, but I guess we can do it the same way. Just because here in the grammar we actually use a block, so I kind of want it to be the same type. Okay, so a function node has a name, list of parameters, i.e. their names, and then the body. We store the body as the list of statements contained inside the curly braces, and then we are ready to update the parser. So if you recall the top level of our parser, it tries to get a declaration, which is great. What is a declaration? We have it here. It's a little bit strange, this code. I think we could just say, it's probably something left over for whatever reason. So we can do this. And else, if we see the fun token, then we need to call the function. So here he puts an argument. So like other statements, the function is recognized by the leading keyword. When we encounter fun, we call function. That corresponds to the function grammar rule, since we already matched consume the fun keyword. We'll build the method up one piece at a time, starting with this. You might be wondering about that funny little kind parameter. Just like we reuse the grammar rule, we'll reuse the function method to pass methods inside classes. Sure. So he is using a string, but why don't we use an enum? So we can say like function kind. It's either a function. This naming might annoy us later, or it's a method. Anyway, let's see how that goes. So we want a function kind function, and then we define the function, which takes mutable self, and it takes the kind parameter, and as always it returns a result statement or string, and then we can say here we probably need to do something like this. Expected, and we'll just debug it. And we need to unwrap it here. And I think we need to do this because it expects a string reference, not a string. Let's check it. Yeah, so function kind cannot be formatted using the debug formatter because we need to say derive debug. And all right, now we get some errors because we added this function statement type in here, because we added this guy, and the match statements don't cover that yet. But we will we'll leave that for a little bit later. Okay, right now it only consumes the identifier token for the function's name. You might be wondering about that little kind, blah blah blah. When we do that, we'll pass in sure. Next, we pass the parameter list and the pair of parentheses wrapped around it. So let's do that. So we need to eat a left paren, and should format it and put a reference. If we don't find the right paren, then okay, we need to make some parameters, and it has to be mutable. So if parameters.size, also this 255 should probably be somewhere else, like a constant. Our error reporting will not be great, I think. How did we do this last time? 255. We did something like that. Let's do that again, even though I would like to have just a function to do that. But you know, that's for another day. So if we have too many parameters, then we just return. Otherwise, we will say param is us consuming an identifier. Say expected parameter name, and we will push it to the parameters list. Okay, so if we don't match, if we don't have a comma after the parameter, yeah, and we break. And once we have consumed all the parameters, then we need to consume a write paren. It's like the code for handling arguments and call. Yes, sure. The other if, hence the zero parameter case. While loop passes parameters as long as we find commas to separate them. And then we get a list of tokens. Is that actually what we get? Yes. Finally, we pass the body and wrap it all up in a function node. So. Don't we have a block statement thing? Okay, the block doesn't consume the left brace. Looks like it's kind of interesting. And we will write expected before body. And finally, we will return a function statement with the found name and the parameters and the body. And let's see. Right, so it doesn't like this because it thinks it's a format string. Let's try to escape it. Curly braces I escaped with. Okay, so we just put 2. And it's not called size, it's called length. And it's not called block. Maybe there was a helper function that I didn't define at some point. So let's say block statement, and then it's the statements we want out. Isn't it? Yeah, it is called statements. But in the function it's called params. And this one has to be wrapped. And no, okay, because it do this. It just knows it's getting a statement. It doesn't know that it's a block statement. And anything else, we will just panic block statement passed something that was not a block. Qualify the name. And now we're back to this problem that the match statements in the interpreter doesn't cover function. Okay, we got some syntax passed, so usually we're ready to interpret, but first we need to think about how to represent a logs function in Java. We need to keep track of the parameters so that we can bind them to argument values when the function is called, yes, and of course we need to keep the code for the body of the function so that we can execute it. That's basically what the statement.function, yes, can we just use that? Almost, but not quite. We also need a class that implements logs callable so that we can call it. So we are doing it somewhat differently. We have the expression here. We have this literal value, which is the values that our language has. And one of those is, maybe it shouldn't be called literal value, maybe, because now it's like functions and things like that, not really literals anymore. But yeah, whatever. Okay, so we have here a callable. So probably when we evaluate it, it should evaluate to this callable. Let's just go in here and see if we can make it make sense. So if it is a function with a name, params, and body that we're trying to interpret, interesting. So let me think about this, because here we are, this is what happens when we interpret the declaration of the function. And where do we have the call? Calling it is an expression. So that will just be up here. And let me see, what is it that happens when we call something? Not that one. Okay, I think it's here. So it will take the name and look that up in the environment. So that means that when we declare a function, we need to make a callable and put it into the environment, which makes a lot of sense. So let's see. a callable is, so the name we already have, let's say the arity is params.length. And now we need to make the function. So that's a little bit more complicated. So it will take a list of values, and we have to bind those values. Function implementation, bind list of input values to params names, or let's say names in params. Add those bindings to the environment used to execute body, and then execute body. Okay. So it's a little bit complicated. So let's try to make a function here. So let's let function implementation equals args, and what do we do? So we need like a new environment. So let's say function environment is equal to a new environment, and then we'll say for arg and args we need the value of the arg. So that should be, no, it already has a value when we get to here, because I'm basically implementing this function. So we will say function, let's call it function env, and also, oops, let's just call it fun. So we need to define, and we also need the index. So to get that, we do something like this. Okay, so here I have the list of names. So I want to define this name to be this value, and that's that. Then I want the let me see. Actually, I could look here because we have this thing already. So I want the enclosing environment to be the current environment cloned. So every time you call the function, it's making a new environment, which is one way to do it. You could also move this out, but then you would have to clean up the environment. So, so you only make one environment per function implementation, but then you would have to clean up the environment every time. We could also make like a struct for this, but I want to try to do this. Okay, but now we have this thing going. Then we have to say the result is what happens when we interpret the body, which is a list of statements, right? Using, and then we actually, let's just do it like this. We need to wrap it. So what happens when we interpret using this environment, and then we can just return that. So actually, the thing is that, you know, functions should probably return values. So maybe we do something like the last value in the body is what it returns. Actually, let me see here. So it is a list of statements, which means we do need to interpret them like this. It's a little bit annoying. So also, what do we do if things go wrong in here? Let's try this. Okay, so that's the function, and then we need to make the callable, which is, for unknown reasons, is a literal value, which has this name. It has, well, we don't need to do that. It has the arity we calculated, and it has the function implementation, which is owned like that. And then we have to say that we define a function with this name and this callable. And then we return OK. Let's try that. Probably it's not gonna work at all. Here we need a semicolon. And like that. So it should be a vector of literal values. Wasn't that how we did it? Yes. Let's check it again. So this was a bunch of tokens, so we'll get the lexeme and probably reclone it. Interesting. And let me see. Okay, it's because okay, so we have to say this, we have to do this thing where we basically do this. we don't need that anymore. We don't need that, and then we have to restore the environment. And that's it. And this one wants a vector of references to statements. I guess we can do that. And because I've made it so weird, obviously there's a lot of room for cleaning up. So now we have this problem of return, right? So it has to return a literal value actually. Otherwise it doesn't make any sense. That's so actually I think we need to do something like this for a statement in body. And basically I want to just interpret all but the last. So we'll say body I, and then I want to get the last one, and I want to evaluate it like we do with the expression. So I want to evaluate with this environment, and just for now let's try to unwrap it. Once everything is evaluated, I want to restore the old environment. We should make a macro for this process, but whatever. For now, whatever. Then we have a value, we return that value. So that should be a literal value. And I think we're good to go. And also we cannot use this one. And we don't need to do that anymore. Cargo, not cargo C. And we need a vector here, so do we have to do this? Yeah, here in the last one we need to say match. So if it's an expression, then we do this. We do this. Otherwise, I'm gonna panic for now. And here we need to clone the lexeme. And we don't have define, apparently, because it's called assign. And it should be like that. And we'll say if this fails, then we return an error, could not define function, else this. And you know what, let's just do this. Could not define function name.lexion. And we don't need the return. Okay. So we have to say, how is it? Borrow mutable. And then C. Now what is the problem? Okay. This function implements fn mute, not fn. Closure is fn mute because it mutates the variable self.environment here. Well, I think it's actually fair enough to make it mutable, because functions in general, we kind of want them to mutate things. So let's see if we can get that to work. It seemed to work, but now we need this. This is not really very good, but I'm just going to do it. And now, what is it? Cannot borrow as mutable. I'm really mystified by that one, so let's go in here and we will say cannot borrow env as mutable. Well, it certainly should be mutable. Cannot move out of arc, but that is just some value. So can I clone it? How do we clone this guy? Okay, because it's an RC. 115. Can I just say it's a reference? No, it doesn't let me do that. what if we say as ref damn. But now if this has to be mutable, then we get a problem with the RC thing. Oh my god. Do we really have to do this? And then we have to say, because it can be mutable in general. Is this how we do it? It is not. Because it shouldn't be just there. Right, this one has to now be a ref cell, and finally we go in here and also put this in a ref cell. Okay, now we get this borrow error again. Okay, so it has this issue that because we're taking borrowing self here, or self.environment, then we cannot use it in other places. So if I do this, maybe one way to do it is to just, so if I put this environment out here, then it says, okay, now I don't like it because the closure is fn once, not fn mutable, because it moves this variable out of its environment. And if I move this inside, then it says that it doesn't work because the closure uses self. And because it's supposed to be an fn mute, then it... Okay, so I want to make a new environment. The new environment has to share the... new interpreter, rather, and it has to share an environment with the... with the old one. So I kind of want to say, it doesn't have to be public. Let's just call it foreclosure, and it should take a, let's call it a parent, which is a self, and it should return a self. And then I want the environment to be this. And the environment dot enclosing should be parent dot environment dot clone, and then I want to return that. Let's see if that can be made to work. So we want an interpreter for the closure, and it has to use this one as the parent. And that means it already has an environment. We don't need to do that. And then we can say function environment is closure interpreter environment. And this one has to borrow mutably. And we don't need this. And we don't need this. This can just be the function environment. We don't need that. Let's see if that works. No field enclosing on. Let's make it mutable. Okay. But what is so wrong with that? Can we just say move? Can I put it in here? Okay. Cannot borrow close into it. That's not declared as mutable. Sure. Value is partially moved here. So it's not, it's getting a little bit gnarly. Yeah, so we cannot do that. So I'm gonna call it this instead. Oops. To avoid having to type too much. So we don't need to borrow mutably here, right? Define, because we have to say environment, and then that is the thing we borrow mutably. And then tons of errors again. Okay, so first of all, I changed this callable type to be just to be an RC of a function, just because the only thing it's gonna change potentially is the environment, and the environment is already inside a ref cell, so I think it's not necessary. Now, I really don't know how to get around this, so what I'm going to do is I'm going to give it an environment, like a parent environment that it's using to evaluate, and then I'm going to give that here as an argument, and then my foreclosure thing, it now just takes a parent environment and uses that to make a new interpreter. So that should work, except that now this one needs to take also an environment, and actually it needs an RC ref cell environment. So let's see if that more or less works. Yeah, then we need to fix this. So what environment should it use? It should use the environment that it's given. Clone that. And now in the interpreter, line 12, or rather down here. No, where is that? 29. Right, so this one also needs to take an environment, which we are not going to use for anything. And now there is a different problem. So it wants it lifetime of this reference is 1 and it has to outlive static. That doesn't sound good. What exactly is the problem? Can we just say okay, after some fiddling around, finally got it to work, and it looks like we have to copy the parameters and or clone rather. No. Ah, yes, now it says. Yeah, so we definitely need to clone the body, right? And I'm still complaining. What if I also clone the parameters? So if we clone both of them, and we have to go through the list and clone what's inside the list for some reason, then it's more happy. So this one we can unwrap, which is not nice, but let's expect and say evaluation failed inside. And then we'll get the name, which is name.lexeme. This will probably give yet another error. Yeah. So we need like to clone the name again so it can own that memory. Okay. Now it's just saying that, well, I guess we can go and remove this now because we're not using it. yet. Okay, that was crazy. So let's try to see if it runs kind of. So function test AB, A plus B. Yeah, so that didn't work. We really need, I mean, I guess we need a return keyword. Because this looks, ooh. That's not good. It's because it's not assign, it's define. I think we are. And then this doesn't return a result, it just does it. And it needs a string, which we will clone. Okay. And now if we say print test2, 3, it actually works. Okay, that was a little bit of a struggle. I'm sure there's something here that's not optimal. But that is for another video. Also, implementing something, so it's not just the last statement, and it just, the last statement looks like super normal. So let's actually try something like this. So we'll say A equals A times 2, and then we return A plus B. And we need to actually start it. Okay. Now if we run test 1, 3, it should give 5. So that the local environment works, and if we print A now, it will say it's not been declared. Great. But we need a return keyword, and probably to optimize this implementation, and maybe we should look into making a struct. Let's write that to do. Make a struct that contains data for evaluation and implements fn. Okay, but see you in the next video, and thank you for watching.